Sorry about the technical difficulties. It's a very ancient laptop, and HDMI doesn't play well with it aside, and problems unite. Okay, my name, for those of you that aren't familiar with me, Jeff Goff. I am currently, hopefully, working for UK2 over in London. So it's been a long flight. Actually, 3 of them. Prague over to Munich, over to Missoula, staying there and back. But enough about me. You're interested in talk. The first thing, if any of you were at London.pm or know my personal taste, you might expect this to have something about origami in it. That's an action. By the way, just to make things clear, that is a cobra, not a python. Just to get that out of the way. And I will also mention that we have an origami BOF coming up on Wednesday. Don't worry, we won't do that one. Although I have a few that are fairly complex. I've been doing this sort of stuff for years. And someone is, I'm proud to say, releasing a programming language for origami on the 22nd, which is unfortunately after the BOF. Bad timing on their part. But that's not what this is about. This is kind of all about me, because I have a little dark secret. I tend to be somewhat of an awful person. I'm pronouncing that specifically because I don't mean awful in the sense of bad, although I'm sure people out there in the Perl community and others would disagree. I mean in the sense of an adult fan of Lego. AFOL. Like these things. This is what's known as my own creation. This appears in no one's set. It's just what someone put together. One of the problems being an expat is that your Lego collection tends to be somewhere else when you're moving around. And if you're like me, and I know I am, you've got like 3 or 4 sets hiding somewhere in a storage locker. In my case, one is in Prague and one is all the way in San Francisco. So I'm kind of reduced to building little things like this, when you really want to be building something like that. That is a real model. I've actually seen that person. That is St. Pancras Station in London, rendered down to the point of individual, the train track there works. There are people standing on a platform, waiting as usual for trains. But one of the problems there too is that that's a lot of pieces, a lot of bricks. And as a lot of us know, Lego ain't cheap. So a good way to build with this stuff is doing it virtually. In this case, with a fairly old but stable and well-worn program called MLCAD, as you can see by the title. Now, MLCAD is not that fancy. It just uses a simple flat file format, which we are going to later on parse out with Perl 5 and Perl 6 as we go through the talk. In section 13 over there, you will see there is just a single line of text for each brick in the model. It's got the type, which is a part. Is it a part, or is it a rubber wheel, or is it steel? It's got a color, and it's got an X, Y, Z position. And that's really all that we need to worry about here for purposes of the talk. That was the cold open. So let's go briefly over the resources that we're going to cover that you will need to know a little bit about. The first one being grammar double-colon common. In Perl 6, I found that regexes and grammars really are pretty much the same thing. They tend to shade into each other, and I tend to use the term grammar and regex interchangeably throughout the talk, and I apologize for that. The second thing you would need to know, of course, is Perl 6, perl6.org. And if you have your laptop open, you can follow along with us on the regexes page from docs.perl6.org. where we'll go through just a very few things on that page. And an additional bonus section here, if we have time, on grammars. And of course, the last thing is the MLCAT format, which has evolved over the years, and I haven't used it that extensively, but I play around with it. So, just to review what we saw on the previous page, we have a simple format. It consists of an X, Y, and Z. I've been in Europe too long. The part name, which is just a DAT file for the rendering for the part, and a color. In this case, you'll notice that it's in quotes because they use the Crayola coloring scheme, which has spaces for names. We'll get into that in a few minutes. So, if you want to parse this in Perl 5, it's a simple expression. You just write that. Everyone here probably knows how to do that. No big deal. No problem whatsoever. Aside from the /W plus over there, we really should have white space as well. Little change, but everyone here should know how to do that. But the thing is, it's not exactly the most legible format in the world. It's not by any means, self-documenting. It doesn't say what it is. You can't tell that you're trying to pull out an X, a Y, and Z. You're trying to pull out a /D, a /D, and a /D. Who knows what they are? There are 3 numbers in a row. They could be, they could be orbital elements for satellite. They could be a listing of zip codes for all we know. Now, of course, you spread out a little bit. It tends to run off the screen a little bit as well. But that's intentional, actually. You can space it out a little bit with the /X modifier in Perl 5. And you space it out even a little bit more. And this way until you have a /D. You have 3 /Ds in a row, a /W. But it still doesn't really tell you what it is. The /X modifier also lets you go in and add comments, so you make it even more self-documenting with comments like this. You have an X, you have a Y, you have Z, an ID and color, all in comments. That's great. That's peach. Excuse me. Now, thankfully, I don't know how many of you have used the name capture feature in Perl. I know I really hadn't until Larry mentioned it. Until Damien mentioned this at the Amsterdam convention last year. I had completely forgotten that this existed until then. Perl 6 has somewhat the same feature, but we can sort of trim that down a little ways and make it a little bit more self-documenting. You see here we have a number. So now we know that X, Y, and Z are numbers and not some weird fixed format thing. And we have, of course, down there an identifier, which could be a C identifier, could be a string. We're not quite yet sure, but we can help with that too. So this is how you could parse that in Perl 5. A lot of detail, and you have numbers. You can tell what it is, a little bit more. And you can even use, because of the name captures, you can even use the %+ array, which probably very few, well, this crowd, most of you already know that %+ exists. In other crowds, I've gotten stares like, does that really work? Yes, it does. So that's where you store the name. That's where you store the name capture fields in Perl 5. So let's change this up just a little bit, and now use the grammar common module from Perl 6, which is already on the ecosystem. I have a lot of new ideas for that. Life unfortunately intruded just before convention and forced me to leave, so I haven't had a chance to really do a lot of the work that I want to with it, but I'll show you some of what I can do. The first thing we can do here is get rid of the /D+, because we don't need to worry about what a number definition is. The module takes care of that for you. And in fact, if you look at some of the models coming up and the St. Pancras display, some of those might not fit into integer coordinates when you're doing your design. So you might need floating point, you might need exponential, and the number here covers all those formats. It covers floating point, it covers exponential numbers, it covers scientific notation, matches all of that stuff. And I see Liz is checking up on me right now. So, next thing, so we have a number here, which we pull in from the grammar common module. It's defined there. You don't need to worry about what it is. It just works. And by the way, it also handles, aside from decimal, it also handles binary, hex, and there will be extensions later on for other formats as I find them. So now we can also get rid of the capture notation, because anything inside the angle brackets is automatically a term that you can capture as part of a match. The last thing that we changed to punch all this down from Perl 5 to Perl 6 is changed from $+ to the more intuitive $/. This being, of course, a new mnemonic, because like in Perl 5, you have $bracket, you have $/, you have $\, etc. Perl 6 trims that down. I think there may be 6 variables like that now. I'm sure someone will contradict me out there. But $/ is the mnemonic for the / operator, so that is the match, the current match. So when you match a string here, I'm ignoring the actual string. When you match a string against, when you try to match a string against an expression, you get back a match object, which is the $/ here. So //$/. Makes life simple. And you also use the same notation that you're all familiar with in Perl 5, $/ brace and then the name of what you're trying to match. These single quotes are no longer optional, but there's a way around that too. So we're trying to match, say, a string from grammar common. We have the string, trying to match the string blue. Now, you might notice here that the quotes are around there, underlined. You might not want those around. So, of course, what you want to do there, obviously, is you want to run that through another batch. But there is another feature in Perl 6, because like Perl 5 data structures, you can nest hashes in Perl 6. So inside of the string here, there is a nested match inside that called the content. So if you don't want the double quotes or single quotes, you don't care about whether it's QQ or Q/ or QWQ, curly brace. You don't care about that. All you care about was inside, you use the contents, or string dash content as well, if you don't want to have the second level of matches. So what you see here as well is that the match object is just another data structure. It can be an array. It could be a hash, a nested hash with data structures all the way down, turtles all the way down, so to speak. You have the nesting, and that is going very slowly down on me. I would swear that I put that higher, but I'm not touching. So you have the ability to do a nested hash, and later on, at the very end we'll show you how to make full use of that. Now, we talked earlier about how things are. We talked earlier about how we want to make things a little bit more self-documenting. So in this case, what we're going to do is rename our match. So we have our string here is quotes blue, 1 quotes, and we want to rename that from a generic string to the word color. This is something that you really can't easily do inside Perl 5. We're getting a little bit more advanced now. So in our early example, we have We have an X, Y, and Z coordinate. And now we can name those as X, Y, and Z. So that when we match our string, we have a nest of hashes. So we have an actual data structure there to work with, a nested data structure, instead of having to use $0, $1, at plus, at minus to go through and try to parse out where things are in a string, go through count parentheses, as we all know and love in Perl 5. You simply use the actual names of what you're trying to match. And you too can create these things such as number keywords as string keywords. You can create those as well and use them in your own regular expressions, which makes, say, the by now infamous RFC matching for email about, I think I've seen you can do it inside of the original BNF because this notation looks like BNF for a reason. Because it really is this is, in fact, we've been lying just a little bit, and that's why the modules call it grammar common, not regex common, because these are really grammars. You can take the string and you can use the same techniques that you would to create a compiler to apply to your regex. So what we're doing here with the labeled hashes, the labeled keywords, we're creating an actual data structure out of our match instead of having to fill around trying to figure out what $0 is, and if $0 is blank, we have to use $1. If $1 is blank, then we have to use $2 or $3. All of those little things that you have to do right now in Perl 5 to figure out where your data is, even after you've gone through and done the match. And by the way, you'll notice as well, the minus sign works. So negative numbers match as well as positive numbers. I think I got to the point where it does complex as well. I'm sorely tempted to add quaternion and octonion, but that's because I'm a math geek. Now, we talked before about how you're wrapping everything into a number, and this design is a little bit complex, as you might have guessed. This is a great ball contraption machine. Its only purpose in life is to pick up a ball from one end and move it to the other via the most bizarre way possible. And this Japanese designer, Akiyuki is his name, and you go on to his YouTube site and see more of these things, designs these things for fun. But you'll notice that some of those pieces don't quite fit into the XYZ coordinates. You have angle pieces, you have pieces that angle up and down, you have pieces that move around and around. So if you were to use your original match with /D, that thing would break it. It probably would break it in more ways than one, but it would break it because obviously you have floating point numbers. And because you can use grammar common, you no longer have to worry about that. So let's take a look at a little simpler model here. This is, of course, a strand of DNA in Lego format. And one of the things that you might notice here is that it has all the alternating phosphate groups. If while we're here, I'm sure you'll be able to go into a lot more detail. The alternating phosphate groups of red and yellow on the side, and the gray, blue, black, and whatnot colors on the inside for the proteins. But for our purposes, what we want to pick out here is that we have a bunch of layers. We have a red layer, followed by a yellow layer, followed by a red layer, followed by a yellow layer. And if we want to sit down and write all the stuff in an MLCAT file, sit down and write it out, layer 1 this way, rotate this degree, layer 2, rotate this degree, layer 3, rotate that way, sit down and do all the calculation, that would be really, really boring. It'd be so much nicer to do something like this, to be able to specify in MLCAD this sort of data structure. This doesn't work, but that's okay. We have Perl. So what we can do as well with the grammar common object, or anything else like that, we can take our 2 times layer operation there, and you've seen some of what we're going to do. We can do this, because grammar common provides you a number and an ident. You plug those in, and you get your match. Pretty straightforward. Now, the beauty of this is that you take the same regular expression as the old style Perl 5, QR expressions, and create your own regex expression that way. This is the equivalent of a QR, sort of. It's close, but not quite. You create your own expression in this case that handles number times value. And of course, because this is all nested and in a data structure, you can find inside our regular expression up there, you can find inside that the match that has the number and the match content with the ident, and nest, nest, nest. So you take your regular expressions and nest those. You can do that too with alterations. The keyword may be there, it may not be there. But right now what we'll just do is match the entire expression. Now this actually works with the module, by the way, because what I've done with grammar common is provide as well an expression module, expression match. So when you go to match text that has any number of mathematical operations, parentheses included, you just drop in an expression in your own code. You don't need to worry about, did I remember to do times or plus? What priority? Does plus go first? Do the parentheses go first? How does that match? You don't need to worry about that. It's all taken care of for you by the grammar common module. You got a question over there, or?
So why do you need the value then?
The value is purely optional. In this case, you have the expression I showed you before here is 2 times layer. By default, it uses a C type expression. So anything that will match a C expression, it will match that. But what you can do there is override that with your own value. Yeah. The grammar common file, you can go in and modify any detail. If you want, you can go in and adjust how it does adjust the priority. And if you want to use, say, grammar common prefix or grammar common postfix, if you have, say, fourth or you have postscript or whatnot, you can use those expressions as well. So it doesn't just handle 2 times 5, it will also handle times 5 2 or 5 2 times as well.
So we'll just go and get whatever local value.
Right. The value bracket, the value there, you're overriding that from the module. There's a default set there already. So you can use that and parse your raw content. Override whatever you want, put whatever you want inside there. Make that, a JavaScript identifier, make that into a PostScript or fourth identifier, or even a common Lisp, if you will. With this module, common Lisp actually is not that hard. It is almost trivial to do, aside from the reader macro and 1 or 2 little niggly things. I sat down and wrote just for giggles, I sat down and wrote a common Lisp parser using this, and it turns out that it's roughly 50 lines worth of text. I'll post it sometime if I find them on my drives, but my drives are right now scattered throughout the world. Somewhat complex life, I must say. But moving on here. It also, of course, handles Unicode. It also because, of course, this is Perl 6. We handle, the proper notation for that would be on the image, if you notice back here, you have the color layer yellow, the red layer, and they are both lifted up and twisted, through a through a certain amount. So one thing that you will want to do there, being a mathematician, of course, I work on radians. So instead pi over 5, you have, so instead of 180 degrees, you have pi over 2. You have pi. Instead of 90 degrees, you have pi over 4. So in this case, that's not quite the right calculation for rotation, but it's close enough. If it's on the diagram, that's the important thing. So you still do all the math work that you want and fill in with your constants. It supports the Perl 6 constants as well as Perl 5. All right, so I talked briefly about, I touched very briefly on floating point. Now, there are a bunch of formats for floating point out there, and some of them have subtle differences. The first one is some floating point formats require, say, A0, require a number to both sides of the decimal, like 1.2. Some of them don't care. You can have 7 point and with nothing following it. You can have 0.35 with nothing before it. And because we want to support both formats, it's a little tricky because you have your floating point here, you have your floating point object, and you want to be able to support both a floating point that parses when you have a trailing 0 and one that doesn't. So of course you can have two different names for them. You can have floating point no, you can have floating point and floating point no trailing zeros. You can have that. But one nice thing about this is because grammars are so much the core of how Perl 6 works, they are in fact classes. And a rule or regex or grammar like we talked about is actually a method. And to that method, you can pass a value, which we'll get to in a second. We're coming up onto the bonus round here. So I'll have to go a little bit slower. And if you have questions, by all means, start with them. Just to review before we go into the next section. For those of you that are interested in Perl 6 and coming from Perl 5 background, most of what you saw still looks like Perl 5. You still have \d, you still have \w, you still have plus sign, you still have dollars, you still have the dollar sign for meta characters, you still have the star. Those all still work. So your knowledge of real expressions can be transported into Perl 6. That you won't lose. You don't lose that, and you gain an awful lot of power. There are a few differences in how the actual parsing works, because now instead of a regular expression like PCRE, we are using essentially parser expression grammars, which means that, and I must be an airplane. Yeah. You have parser expression grammars, which means that you can take the same technique. You can take a regex value and build onto that a regex expression. You can build on from that a regex parentheses function call. You can build onto the function call a subroutine. You can build onto the subroutine a file, and you have a parser for an actual language. It is now that powerful. And in fact, the parser that we're using here to do this dirty work is the same parser that is reading that code and parsing it. So if it's powerful enough to read that code, it's powerful enough to read any code, with the exception possibly of brain expletive deleted. that one, and there's also, Malbolge might be a little bit of a stretch, but I actually have on my GitHub account, which I should put up there as well, github.com/dr4. I also have a partial parser for the emoji code language, which has literally all of the blocks and subroutine calls and all of the function names are all emoji. But another important thing there is how powerful it is now to compose things instead of being able to just have a QR variable that you interpolate and then scratch your head trying to figure out, okay, do I need to use backslashes here, or do I need to use an eval to get this over here, to get this to nest, or do I need to use the curly brace notation? It all nests cleanly. You can build regex on top of regex on top of regex. And in fact, you can go a lot farther than that. You can take your regexes and package them inside a regex object. You can use that to build on further regex and parsing tests, and start out, as I said, grow and grow and grow, and create your own file, as I have with the grammar common. So let's move into the bonus round here. This is where I've learned things. Okay. Just to reiterate where we were, we have a X, Y, and Z. We're not going to worry right now about strings or anything fancy like that. Right now, we're going to use the string, just a simple string of 3 numbers. The tilde there is the first time you've seen that. That is the new version of the match operator. This is also, for those of you from Perl 5 who may be a little bit weary of what looks like a smart match operator, in fact it is. The smart match operator was designed for Perl 6 and Perl 5, in a decision that a lot of people are regretting, decided to incorporate that, and is now being removed. That's because Perl 5 and Perl 6 don't share the same type system, and those things don't quite work out. In Perl 6, smart match is where it was meant to be, with proper typing, and that gives you the ability to do smart matching of arrays against scalars, and in our case, say scalars against real expressions, which is the whole point of why we're using here. Now, I've also changed things a little bit slightly here. You'll see down there, instead of using the $brace quote notation, I'm using $/ and then angle bracket notation. That is a little more consistent because we have, in our real expression, we have a number. We have a number surrounded by angle brackets, and in our match, we have numbers surrounded by angle brackets. So you take one string, copy that, paste it down below. No need to change things. No need to flip in your mind. Am I looking at a hash or am I looking at an object? No need to flip between those two things. The output there is not quite what you'll see if you are trying to run statement in Perl 6. I see a few people typing, and I will let you know that you'll see a little bit more text there. I'm just using this right here to make the example cleaner. In reality, we use the Japanese quotes around numbers inside the string there. That's just a little bit more clutter than I think we need on the screen. So I eliminated that. Now, the first thing that you see here in the real expression, we're talking a little bit about how we want to keep these things clean and self-documenting. The /s's there, they're a little bit redundant. You don't really need them. They don't add anything to them. All they do is keep the two things apart. Like, I'm trying to remember the old quote about The only reason time is around is to keep everything from happening at once. That's how I feel about white space there. The only reason the white space is there is to keep the numbers apart. So one thing we can do here is, okay, we have one more slide before we do that. I screwed that up. Okay, we have one more slide here. I thought that was a point, but anyway, the X here and Y. So let me back here for a second. We talked about self-documenting code, and here we have 3 coordinates, X, Y, and Z. What we want to do is be able to make that more self-documenting. And right now we have number, number, and number, which is why Perl 6 gets a little bit confused when you ask for the number down there. It says we have 2 or 3, and it says, okay, I don't know which number you mean, so I'll give you all of them. So that's why down there we have the angle brackets around 1 and 2. So it'd be nice, because we know those are coordinates in 3-dimensional space. So what we want to do there is label those with X, Y, and Z. And luckily in Perl 6, we can do that. We take our string and label it in X, Y, and Z. So now we still have the number there to work with, but we can go in there, and I forgot that bit. You can also use $/race X as well. So you have the number there to work with, the actual number, and you have the name that you gave that for the number. So you can take your expression from our grammar and give it your own name.
Why is it 1 and 2 and not 12 and 4?
That would be a typo there on my part. Yeah, that should be 12 and 4. I added a few of these slides literally a few minutes ago, a few minutes before talking. I apologize for that. Yeah, so that confusing. My apologies. Okay. The last thing here that we want to look at is what I alluded to earlier, is the white space between the numbers. Because especially in a red expression like /d/s/d/s/d/s/w/s, the slashes really don't add anything. So what we're going to do in Perl 6 is, instead of using the regular expression, regex, we're going to use a rule, which tells Perl 6 to ignore the white space. So you no longer have to worry about that. There is a way, of course, to make white space significant inside, but we don't talk about that for right now. So what that lets you do right there is remove. You'll see here we have the old expression up there at the top, and at the bottom we have just rule line and number, 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 with no /s. So that way you have token, 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 which if you remember if you were in other talks, you may see notation like B and F. I think that was shown at one of the keynotes. But the important point for us here is that the B and F notation and Perl 6 notation are very close, and that is by design. In fact, another talk that I brought with me, I discussed my Antler parser. For those of you that are familiar with Antler, it is a grammar toolkit based loosely on Yak and Lex. What I do with that is I take the Antler grammar output file, and they have Antler grammars for Java, for C, for PostScript, for Forth, not for Perl, oddly enough, go figure. Python. What my program does is it takes the original Antler file and rewrites it into Perl 6. And thus, when you take that file and compile it in Perl 6, you now have essentially if you give it a C file, You get out the other end, you get a Perl 6 version of a C parser. You have to do some tweaking here and there. Obviously, that's the way the ANTLR grammar works, unfortunately, but you've got the basis for what is a C parser or a Python parser. So you can use that to write your own Python parser in Perl, your own JavaScript parser in Perl. And if you come down to the tutorial on Friday, I go through, and at the end, we will work through a sample, very small parser and compiler of your very own to do JavaScript. That's one of the exercises. So that gives you a taste a little bit, I hope, of how powerful this is. And the ANTLR source to translate to C is in Java and roughly 200,000 lines of code. By comparison, my version in Perl 6, I think it clocked in at 48K of actual Perl 6 code to do what the ANTLR parser does in 200,000. Like, I think the object file is on the order of half a gig to do the job. So, moving on. I missed a slide there. Oh, okay. For our old example, this is a truncated output of what it looks like, what a match will look like in Perl 6. All of your data is still there. All the nesting is still inside there. All you have to do is say the object. Unlike in, say, Perl 6, where you'd have to go, unlike in Perl 5, where you'd have to look at $0, look at $1, look at @, look at @+, look at @-, all those variables inside there. You have everything in one single data structure. So if you want to debug, all you do is say $/. There's no need for data dumper, no need for DD, no need for debugger. You just throw in a say statement, and you get the entire object output. You see the entire tree, which can be a little bit awkward if you're looking at a large data structure parse, as I routinely do with the ANTLR stuff. But it's all there. It's all laid out for you. There are one or two slight issues that I have with the output, but that's a different story. Now, at last, what you might want to be able to do with this is actually capture the output and do something more with it. So one thing that you can do is use grammar common in your own grammars with the does category, with the does keyword. So you create your own grammar and glom onto mine, so you can steal all of my good stuff and put it into your own, like this. In the word top there, in Perl 6, all of the, in Perl 6, keywords for reserved variables are, Larry and Liz know the term better than I do, are all uppercase, so they don't conflict with anything else. In this case, top means the very top of the grammar. If you are parsing, say, C, you will want to parse, if you want to parse, say, JavaScript, you parse, your top rule is the top function, or the top file, listing subroutines inside there. Or in C, you would have a file. Your top rule will be a line, listing files. In our case, it's going to be nice and simple. What we're going to do is just take our top rule here and parse this out using a separate parser. I don't know if I got to the point of being able to actually write an action here, but we'll see very shortly. All right. So I did do that, right. Okay. One other thing that you can do with the module eventually is do a little bit more with the do a little bit more with the stuff inside. You'll see here I do the MLCAD grammar includes grammar common. I've got other tools inside there. All right, cool. Yeah, inside that I have at least one and intend to write more. As I said, life kind of intruded on me halfway through writing this module, so that's how things work. So we are, so one thing that you can, other things that you can do with this, you can create your own interpreter using what I have here. So if you want to say, this is a little bit more complex, but what you're doing here is you're using my MLCAD, you're using the MLCAD grammar from here, capturing an expression, and you can use the built-in interpreter inside Grammar Common, which will interpret the expression parent 2 times 7 plus 1 and give you an actual value without you having to do anything. You can use the actions that I created. You can use the interpreter that I have there. I think I started on that before things went haywire on me. But what you can do there is use my interpreter superclass, and you steal my code, and you have an interpreter. Or if you want to get really fancy, you can also, I have plans to also create a AST tree so you can do your own compiler. That will take an AST. You chose how you want the AST, but I generate that for you. So you have a bunch of terms. Line down. And all you need to do is you steal my interpreter code there with the does keyword. Back here, you steal grammar common with the does keyword. Apply to your own grammar. And with a little, and you want to create, of course, your own interpreter there. So this is a simple way to, I mentioned earlier, sneaking in just a little subtly, that regular expressions are just functions. And this is where we use that. We have a function, we have a regular expression inside Grammar Common, and we have and Liz is squinting, which means I have a typo somewhere. Yeah. Or something egregious, or something equally egregious, which she'll berate me for later on. The expression here happens to be what Perl 6 will run when it doesn't match. So you have both the match that you can do. You match X, Y, and Z, and you can tell the compiler to do things when it encounters the number, when it encounters a string, when it encounters your expression. You can tell it to, instead of just matching on 1, 2, and 7, you can have it add 1 plus 2, which is what this does. So this module here handles all that for you. It is a trivial bit of work, but it does show a little bit of the power of what you can do. You can also, if you want, override some of what I do. You need to do a little bit more work than just this. But what you can do is inside my grammar, you can use mine and stitch things together to add in your own operators. So you're not limited to plus, minus, times, mod. You can add your own, like XOR, like NAND, like zip, like sigma. You know your own there. Again, Liz is squinting. There is more code that you need. There is more code that you need than just that to support that, but it will work. You know, so, and this unfortunately runs off the screen, there should be both a prefix and a postfix version of the grammars. I spent most of the time working on the infix side, but you can also take the expression and use a prefix or a postfix expression. I haven't gotten around to doing a full Lisp in there, but since I think I allow for parentheses in prefixes, you can use that. So I'm hoping that this gives you, if not a sound grounding in grammars, at least an idea of what lies beyond in Perl 6 in terms of the power, in terms of the simplicity, in terms of ease, and I thank you very much. All right.